Alright, so I want to continue this this example that I began last time, which is counting the number of passwords that have various sort of parameters. So the one we looked at in the last video, or at least that we started to look at, was counting how many passwords consist of 6 lowercase letters, 1 uppercase letter, and 2 digits. So let's answer maybe the easier, I don't want to say easy necessarily, but maybe the more straightforward of the two questions. Let's go ahead and address that straight away. So I want to keep the requirements for the password here: 6 lower, 1 upper, and 2 digits. So I left off the last video saying that formatting was going to be the hardest part of this whole scenario. Alright, so formatting is our biggest issue. So what I want to do first is let's just stick to one format for right now. Alright, so let's choose a representative format. Alright, and this just really means that it doesn't have to be this format in practice, but we're just using this as like our example. Alright, so let's choose a representative format. For instance, e.g., let's have our uppercase go first, our 6 lowers go second, so to speak, and our 2 digits go last. Alright, so these will be the decisions we have to make. Nine decisions in total, 1 uppercase letter, 6 lowercase, and 2 digits. And now you want to ask yourself, okay, how many ways could I choose the uppercase letter? And of course there are 26 letters to choose from, so you have 26 for each one of those. Same can be said for every one of these lowercase letters. Right, there's 26 for all of those. And then your digits, all digits between 0 and 9 are available, so we have 10 for each. Alright, and now our generalized fundamental counting principle says that we should take all of these 9 decisions in total that we have to make, and we should multiply them all together. Alright, so we're going to have a lot of 26s multiplied together, and then 2 10s. Alright, so how many 26s? Let's see here. There's 6 lowercase letters and 1 upper, so that's going to be 26 times itself 7 times. So that's 26 to the 7th, times 10 times 10, so that's times 10 squared. Right, and this is going to be a very, very large number. You know, using a calculator or something like that, you can work out what this is approximately equal to. For the sake of brevity and of exactness, I think it's nice to leave it in the form that it's currently in. Because this is a 100% exact answer, and it's digestible, right? It's not going to be like 13 digits long. It just is what it is, and you can write it down, and the reader will know exactly what you mean. In particular, I will know exactly what you mean. And if you leave your answer in this form, I'll see kind of a sense of how you got there, whereas if you give me some number that's like 13 digits long, I don't necessarily see how you got there. So let me tell you what this approximately is equal to. Alright, so 26 to the 7th is 8031 810 176, and then multiply that by 10 squared, which is 100, and that just adds 2 zeros on the end. Alright, so if we start putting our, just to get a sense for what this number actually is, right now it's just a string of numbers. I have no intuition for what this number really is. So let me start putting my commas in here. Right, go 3, and 3, and 3. Does that look right? Yeah, that's right. So this is, let's see here, this would be 100 millions. So this would be billions. Rather 100 billions. So this is 803 billion and change. That's a lot. All right, so there's a lot of these passwords. And remember, this is only in one representative format. And what I mean when I say that is that, say you go to a website and it tells you your password has to have 6 lower, 1 upper, and 2 digits. Well, maybe some of you will say, okay, I'm going to put the uppercase letter first, like we have here, and then I'm going to do all 6 lowers, and then I'm going to do my 2 digits. However, some other people out there might do a different format. They might do lower, digit, upper, lower, lower, digit, lower, lower, lower. Right? This is another perfectly acceptable format for a password. And just eyeballing them, there is absolutely no way that this password and this password could even feasibly be the same password. Right? The order in which you write your digits and your letters and everything in your password determine what your password is. All right, so just looking in the first position here, the fact that this one starts with an uppercase letter and this one starts with a lowercase letter means that right away they can't be the same. All right, so what that means is that we've got to figure out a way of counting all of these different formats. Within any individual format, we're going to have this many passwords. We're going to have 803 billion, or as a shorter form, we are going to have 26 to the 7th times 10 squared. And that's within any given format. All right, so within this format that I just drew down here, there will be 803 billion more passwords. All right, say you mess it up even more, right? Say you switch this lowercase letter in this digit. That's a new format. There will be 803 billion more passwords than there just were a second ago. All right, so let's take a look at the only thing we couldn't really do, right? What's going to be basically the same format as far as we're concerned? Well, that would be a situation like if you interchange these two lower cases. Right, so in your actual password, you would have letters here, right? This would be like, lowercase a, and this might be lowercase b. And if you interchange those two letters, then you will fundamentally change the password. They'll be different. However, we're not talking about specific letters right now. We are just talking about what kind of character is going to go in these addresses, right? What kind of character is going to go in these locations in the password. And as far as the format is concerned, lowercase letter and lowercase letter are the same. All right, they will generate the same number of options from a counting perspective. So, interchanging two lowercase letters does not change the format itself. All right, similarly, interchanging two digits will not change the format itself. The only thing that's going to change the format is doing something like, moving a digit over to where a lowercase letter just was, and vice versa, right? That will change the format. But interchanging like types will not change the format. So what this is really saying is the following. All right, how do we actually count these formats? That's the big question. All right, how to count password formats. That is the big question that we have to answer right now. And the idea here is by figuring out how many ways could we choose. I'm just going to pick one of the character types to start with. Because there's only one of them, I'm going to start with the uppercase letter. All right, so how many ways could we choose the position of the uppercase letter? Which I'll shorten just to calling it an upper. How many ways could we choose the position of the uppercase letter? we're going to have to answer this question for all the different character types, but we have to start somewhere. Remember, I said this is going to be a mantra in this class, and it really, really is. All right, we have to start somewhere, so let's make it simple. Right, let's start with the thing that there's only one of, which is an uppercase letter. How many ways could we choose the position of the upper? Well, hang on. Before I move to the next page, let's go ahead and count the spots that we have here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 characters that go into this password. Right, so what this really means is that there are 9 positions available. All right, so there are 9 positions available. And right at the same time, we are looking to put 1 upper, 6 lower, and 2 digits into this password. All right, so first, let's find a position for the uppercase letter. So just starting out, right, knowing absolutely nothing about this password, meaning it's a totally blank slate, and we have to take these 9 positions and populate them with an upper, 6 lower, and 2 digits. Starting with the uppercase letter alone, 4, 5, 6, 7, 8, 9. Well, the uppercase letter could go in any of these spots. Right? There's nothing stopping us from putting this uppercase letter absolutely anywhere in this password. It could be anywhere, right? And since there are 9 positions available, that means there are 9 ways we could position the uppercase letter, which I'm abbreviating even further here to just calling it U. All right, so there are 9 ways we could position the uppercase letter, 1 for every single available address in this password. And by address, I just mean position where the uppercase letter would go. All right? Now, let's say we have chosen the position of the uppercase letter. Now we need to do something else, right? We need to do something second. So we've chosen the position of the uppercase. It's in one of 9 spots that are available. Now we've got these 2 other character types to choose from. Because it's a smaller number, I'm going to go with 2. All right, let's say we want to pick the positions of our 2 digits. All right, so 2 digits. And now here's what we have to address. We've already picked a spot for the uppercase letter. All right, so we've already picked a position for the uppercase. How many available spots does that leave open for digits? All right, well, let's just look at the diagram I've already drawn, right? Let's say we pick that the uppercase is going to go in the 3rd position, right? The 3rd character in this password. Well, that leaves, let's just count them, right? 1, 2, 3, 4, 5, 6, 7, 8 left. Right? We didn't really need to count that out. There are 9 spots, that's 9 ways that it could be chosen initially. We've picked one of them to be an uppercase letter. That leaves us with 8 spots left. All right, so 8 spots left available. All right, 8 spots left for 2 digits. All right. I apologize if you can hear my neighbors in the background. It's a beautiful day, so the windows are open. So, 8 spots left for 2 digits, and remember what I was saying back on this page, in light blue right here, right there. If we were to interchange the positions of 2 digits, that would still be the same format for a password. Just like if we were to interchange any 2 lowercase letters, their positions, that is, that would be the same format for a password. So what this is saying is that order doesn't matter for the individual character types. Alright, so order doesn't matter for character types. Of course, once you start choosing actual characters to fill in those positions, it will matter. Right? If you have AB in your password, that is a different thing than if you have BA. Alright, so we're still just talking about formats here. That's really crucial. Alright, interchanging 2 digits in a format will still give you the same format. Okay, so what that means here is that we have 8 spots left for 2 digits, and order doesn't matter. All right, order doesn't matter for the 2 digits. Two digits. All right, so 8 spots left for 2 digits. What this means is that we are looking at the situation where we want to choose 2 things from 8 possibilities where order doesn't matter. All right, so we want to choose 2 things from 8 if order doesn't matter. Apologize for the silence, weird silence there. My daughter is currently doing toddler social distancing out a window with another toddler, which is pretty darn cute. Okay, so we want to choose 2 things from 8 if the order in which they're chosen doesn't matter. All right, so the actual order of the digits doesn't matter. They both generate. Either way you choose the order of the digits will not affect the format of the password. And this is something that we answered, or started to talk about anyway, in the last video. All right, so first, how many ways could the 2 digits be chosen from 8 if order did matter? All right, so how many ways could we pick them if order did matter? And the answer here, right, you're just trying to choose 2 digits. And so there's digit 1 and digit 2. There are 8 ways of choosing the position. Remember, we're choosing positions now. That's what this is really saying. There are 8 positions available for the first one, and then only 7 for the second. So the fundamental accounting principle says that there are 8 times 7 ways of choosing the position of the 2 digits if order mattered. All right, and what we did last time, in the last video that is, was to say, okay, this is how many ways there are of doing it when order matters. Let's see how many ways there are of reordering these 2 digits that we've just chosen in some order. So now divide out. Right, so this is what you do second. Divide out the number of ways of reordering the 2 digits that you've chosen. And the number of ways of ordering the 2 digits that you've chosen will be 2 times 1, right? 2 factorial, if you want to think of it that way. Right, so what this is saying is that we have 8 times 7 divided by 2. In other words, 4 times 7, just canceling, the 2 out, making that a 4, which is 28. So this is 28 ways of choosing 2 digits. Positions for 2 digits if 8 spots are available. And order doesn't matter. All right, so this is a very long-winded way of answering this question back here. All right, 8 spots left for 2 digits. So 8 spots left for 2 digits means that the number of ways of choosing those positions for those 2 digits from the 8 that remain, we just answered here. It's 28. All right, so let's remind ourselves what's going on here. All right, so first, choosing the position for U from 9 available spots, there were 9 ways of doing this. Choosing the digits, trying to ignore my daughter carrying on a conversation with another toddler out the window. The number of ways of choosing the digits is what we just did second. We tried to pick 2 positions for them from 8 available, and we just saw that there are 28 ways of doing this. And now, let's look at what we have to do third. Right, we've got a third character class here, which is the lowercase letters. So now we have 6 L's to put in how many positions? Well, we started with, let's just keep a running tab here, we started with 9 here, and we picked 1 spot for U, so that knocked us down to 8 here for the 2 digits. So we did that. That leaves us with 6 spots remaining. All right, so 6 lowercase letters to be put in 6 of the remaining spots. And how many ways can this be done? Well, it can be done in, because the order doesn't matter that you put them in, this can be done in exactly 1 way. All right, so there's only 1 way to do this. All right, so let's just look at an example of what I'm saying here. When I say there's only 1 way to do this. All right, so let's say that we've got our 9-character password. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now let's just start choosing in the way that we said we would. Right, so first we would choose an uppercase letter. Right, so let me do this in light blue. I don't really know where to put it, so I'll just put it right there. Right, let's say that's the spot we picked for our uppercase letter. Now, let's do the digits, because we're doing those second. We picked 2 of these, so maybe I'll put 1 first, and I'll put 1 fourth. All right, now, I'm trying to pick spots for my 6 lowercase letters, and if you look, I have 1, 2, 3, 4, 5, 6. In terms of formatting, there was no other way I could have done that, given that I had already put the uppercase letter down first, and the 2 digits down second. Alright, so the 6 letters come after that, and they have to go in the 6 spots, the 6 positions that remain open after assigning the first 3 characters, namely the first being the uppercase, and the second and third being the 2 digits. Alright, so there's exactly 1 way of assigning those 6 lowercase letters after you've already assigned the upper and 2 digits. Okay, so putting this all together, let's see if we can tie a bow around this. So, choosing a password. All right. So what we're saying here is the following. We get to pick a format, and then we get to pick the actual like letters and numbers that go into the password after we chose a format. All right, so actual U, L, and D. Right, the uppercase letters, lowercase letters, and digits. Right, the actual uppercase letters, lowercase letters, and digits that will make up your password. All right. So, viewing it this way, this is now like a fundamental counting principle point of view, because we have to make one decision, which is what format will this password have, meaning where will the uppercase letter go, where will the 6 lowercases and the 2 digits go, and then the second decision we have to make is the actual letters, right, the actual stuff, the actual ingredients that go into this password. What are the letters, what are the digits? All right, so the number of ways we can make this decision. Well, in terms of formatting, we had 9 ways. Well, let me take a step back here. We have to make 3 decisions to decide the number of formats. One is how many ways we can decide the position of the uppercase letter, which we said there were 9. And then the number of ways of choosing the digits, we said were 28. This was choosing 2 things from 8 if order didn't matter. And then the number of ways of assigning the 6 lowercase letters last, there's only one way to do it because there are 6 spots remaining. And now the actual upper, lower, and digits. Well, no matter which password we looked at, right? Let's draw out an example here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So remember, I did an example here where I said, okay, we're going to put our upper first, and then our 6 lowers, and then digit and digit. And we said, okay, we've got 26, 26, 26, 26, 26, 26, 10, 10. All right, so now we multiply all of these things together to get our final answer, and this is all by the generalized fundamental counting principle. All right, so we're just going to have a gigantic array of numbers, a gigantic line of numbers multiplied together. And the reason why I put this multiplication in the middle is that this situation describes the first decision we make in creating a password, which is the format. And this situation describes how many options we have within a given format of actually creating that password, meaning the total number of ways you could actually pick the letters and numbers. So, because it's 2 decisions made back-to-back, we would use a fundamental counting principle and multiply the number of options first and second together to give us the total number of options available. All right, so the generalized fundamental counting principle says that the number of passwords with 1 upper, 6 lower, 2 digits is the following. It is 9 times 28 times 26 to the 7th times 10 squared. And remember, before multiplying by 9 times 28, this number by itself was already 803 billion. So, let's see what this number is approximately. And again, this number, the way it is right now, is a perfect final answer because I can decode this. Right? I can look at this and say, okay, this person thought this, 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 and this. And it's either right or wrong, but that's not the most important part. The most important part is the thought process that led you to it. So let me give you the approximate form here. All right, so this thing is about 2.02, I'll throw another decimal place on, 024 times 10 to the 14. All right, so if you really wanted to see what this number looks like, this would be 2, 0, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Roughly speaking, this is how many passwords there would be. Put the commas in there if you want to get a sense in terms of billions, trillions, quadrillions, but there it is.